Hi, and welcome back to Hacker101. This is the final in a series of 3 sessions on cryptography. If you haven't watched the first 2 yet, I recommend going to check those out first. In this session, we're going to talk about some final thoughts on crypto and some handy tips and tricks. So let's jump right in. To detect ECB mode, if you have some control over the data being encrypted, repetition makes it obvious. This is because each block is encrypted independently in ECB. With 47 of a given character in a row, I typically use A for this, you're guaranteed to see some repetition if ECB is being used with a cipher having a block size of 16 bytes or less. No matter what comes before or after these characters, you'll be guaranteed at least 2 solid blocks that should match. Once we have repetition, figuring out the block size itself is trivial. Just change one of your A's to a B, then you'll see a gap in that repetition. The size of that gap tells you the block size of the cipher. Once you know all that, you can use repetition to figure out exactly where you control data. Consider what happens if you change bytes at the beginning of your encrypted payload without seeing any impact on the repetition of blocks in the ciphertext. This will tell you you're offset from the beginning, while doing the same to the end will tell you how far you are from the actual end of the crypto. And now a couple little notes on padding oracles. Bear in mind that these only come into play when you have data encrypted in CBC mode due to the way that the XOR chaining works. Additionally, you must be able to manipulate the data. If there's a properly implemented HMAC or the like, it's invulnerable to padding oracle attacks. This bears repeating. This is part of why you should always encrypt and then MAC. If you decrypt before checking the MAC, then padding oracles are possible again. In terms of detection of padding oracles, the only real way is to try exploiting them. If you try all 256 possibilities for the last byte of the last block, you should see at most 2 valid values. 1 and whatever the original padding value was, if it wasn't a 1 already. Once you've done that, check the second to last byte to determine when it's a 2, etc. Padbuster is a great tool for exploiting these in practice, rather than writing your own, although I do recommend that as an exercise. It's really fun to watch it work in practice. Now, you've likely heard this from others, but please, unless you and a panel of other crypto experts are working together, do not design your own crypto protocols. There are great off-the-shelf libraries like Keyzar and Salt, which provide high-level functionality rather than crypto primitives. Building your own crypto systems is a great way to learn, but please never use your own designs in practice. Even experts get this wrong constantly. In terms of crypto systems to actually use in practice, the advice I typically give is this. If you have data in flight, use TLS. If you have data at rest, use PGP. These will cover most cases no problem. And finally, let's talk about the mortal sins of crypto. Never MAC then encrypt. You leave yourself open to so many more attacks this way. Never use hashes when you should use a MAC. Hashes are not authentication. Never reuse key IV or key nonce pairs. This is how you end up leaking data as well as letting attackers decrypt data freely. And lastly, never ever 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 use ECB mode. There's absolutely no reason to ever use this mode. While there was a lot of content in this series of videos, and that can certainly be overwhelming, I hope that this has given you a bit of a taste of the fun things you can do with cryptography. If you'd like to go forward and learn a whole lot more, check out the CryptoPals challenges. These are freely released at CryptoPals.com, and if you complete these, you will be able to deal with practically anything that comes up. As always, thanks for watching, and happy breaking.